Hello, we are Team 21, creators of the Kia Entertainment System. So to start with some background on this project, this was proposed to us by our advisor Dieter van der Elst and is a collaboration with the Cincinnati Zoo. The goal is to create an enrichment activity for the Kia birds. These birds are natives of the northern part of New Zealand. They're highly intelligent and they're a vulnerable species. The problem that we're trying to solve here is that the Kia, being very intelligent, needs some sort of intellectual stimulation to be happy in their environment. And the zookeepers want to show the guests how smart the Kia can be, as well as understand themselves just how intelligent these birds are by pushing the boundaries with new problems. So our solution is essentially a games console that can be played by the Kia. This allows it to be versatile, only limited by the software and the amount of inputs you have on the controller, and extendable to multiplayer. So Kia versus Kia, or Kia's playing against zoo guests, is an option. So here you can see a diagram of our design with the Kia and the zoo guest on opposite sides of the enclosure. In our final design, the Raspberry Pi and the game controller were incorporated into one box, but for the purposes of this diagram, this shows you how it all works together. So the system is really nice. Like I said, it's got a lot of versatility with the Raspberry Pi. The controller also allows for good tactile feedback with its buttons, and the speakers allow for some nice audible feedback. So to give you more background on the controller and its internals and how it works, I'm going to pass this off to Robert Betchman.
For the controller, we decided to use an Arduino Leonardo. We initially were going to use an Arduino Uno due to the Uno's small size and amount of I/O pins. However, the Raspberry Pi in this system was designed to have a keyboard press as an input rather than a high or low signal from the Arduino Uno. After some research, we found a software library that allowed the Arduino to output a keyboard press rather than a high or low signal. However, that library cannot be utilized by the Arduino Uno and instead only by another board called an Arduino Leonardo. For that reason, we replaced the Uno with the Leonardo that is currently in the system. The buttons were chosen because they have built-in LEDs for one. These LEDs would easily indicate to the player that their input was received, and the buttons were also chosen due to their robustness. The 10 kiloohm and 220 ohm resistors were used as pull-down resistors and current limiting resistors to the LEDs respectively. Here you can see the whole circuit. As you may be able to tell from looking at the circuit, pressing a button will send a high signal to that button's corresponding pin. The board then will send a high signal to the pins out to the corresponding LED, which will then illuminate it, indicating to the player that their input was received.
In terms of console power or the computer, we chose to go with the Raspberry Pi 4. We chose this because the Raspberry Pi 4 is compact. It boasts of more RAM than any of the other options at 4 gigabytes as opposed to just 1 gigabyte of RAM. And we also chose it due to the open source nature of Linux and Python, which is what powers and runs the Pi. Therefore, we can create games and modify the OS without any extra upfront cost, as opposed to if we were trying to do this over Windows or Mac OS, this would be harder. It also has many USB headers for possible controller inputs. There are 4 of them on the Pi. In this case, we can potentially have up to 4 players playing against each other if we wanted to do that down the road. And it also has HDMI output for display purposes. This is important due to it being the universal output to a screen and supported on many screens and other devices as such. Now I'll show you sort of how the game works for the Simon Says game. Again, it's a Simon Says game standard pick the colors in the order that they are shown, pattern recognition. In this case, it can be controlled either by the zookeeper or by the birds. The birds would of course click the corresponding buttons that would light up. They are mapped to the RGB Y keys on the keyboard. And for the zookeeper, if for some reason they need to refresh the screen for the birds, it got too hard for them, the birds lose focus and they want to put something on screen or change games, we have mouse controls where the zookeeper can click on the physical buttons on the screen and progress the game. So let me just refresh. So in this case, we can see that it shows up as yellow. So if I press the Y key, it will light up yellow. The score will increment to 1 and the pattern will continue. So now it's yellow, red. Now if I use the keyboard by pressing Y and then R, it completes the pattern, it increments the score to 2, and it keeps going. So now it's yellow, red, yellow. So Y, R, Y. And it goes like that, and it goes incrementally. Now, if you say mess up and say, for example, it wants yellow, red, yellow, green, instead I press blue, as you can see, it shows that you lose, and then it decrements the score back to 0, and you start all over from the beginning of a new pattern. And this is how the game progresses. Now I'll pass this off to my compatriot John Siegel, who will go over the controller design, the design of the box, and how the device works and how the Kia will be using the device.
Thank you, Max. Now I'll cover what the controller is like and how it was built. So, as you can see, the controller here has a hasp on the outside, or latch, and it has a lock on the bottom so that the Kia can't pry open the controller and get to the electronics inside. There are 5 buttons on the top, 4 of which have colors, and 1 of which is clear. So if I were to press this button here, this box hasn't been painted yet, but on this corner there's a little blue outline. There's actually a blue LED ring that will light up if I press it. And there's a little click for feedback here. And this one also has a more audible click to experiment with which button the Kia would prefer more. So this box was also constructed with maple wood for the middle sections of the box, and then walnut for the top and bottom pieces. And this is to ensure durability and also weather resistance, because these woods are very good in the elements. There's also hinges on the back here so that the box can of course open, and then we drilled some holes in the back so that we could feed wire through. Now to unlock the box, inside is where some of the equipment lies. So this is an HDMI splitter, so we can display to 2 screens, the Arduino Leonardo and prototyping board with all of the wiring correctly shrouded and covered so that nothing will short out and it'll stay weather resistant. So overall, this box probably took maybe 10 hours to build. I'd never done woodwork before and wanted to learn, so I did some with my uncle, and I think it came out pretty well. Overall, in testing, the Kia were pretty interested by the box, and they really liked this clicky yellow button, so that might be a future consideration. And the buttons are also held in by a silicone sealant, which worked very well for the birds. They were not able to pry the buttons out, and they seemed to hold just well enough. And one of the benefits to this as well is it's really good at sealing in terms of keeping the weather out. That's the kind of sealant that I would use on like a valve cover gasket for an engine. So if it can keep oil in an engine when it's under high pressure, I'm sure it can keep water out at a low pressure. So that happens to be a cheap and effective solution at keeping the buttons in, and you can also pop them out with enough force but the Kia can't generate enough force with their beak to pull these out. So it ended up being a perfect, cheap, easy solution for me. Thank you everyone for watching this video. I hope everyone is staying safe out there, and go Bearcats.